All right, greetings, scholars. Beautiful mind here. So we have this question that comes from Calculus for Business. This comes from section 2.1, exponential and log functions of base E. Um, I'm going to click on view an example, right? So we're going to work with this, if I can get it to display properly. So it says a cup of hot coffee is placed on the counter and allowed to cool. The temperature in degrees Celsius of the coffee T minutes after being placed on the counter is given by this function. So then it has four parts to it. And part A says, what was the original temperature of the hot coffee? So this formula here, this is the temperature of the coffee. So capital T is telling us the temperature, lowercase t is telling us the time, right? So this is the temperature based on the time after being placed on the counter, right? So again, this is the temperature based on the time. What was the original temperature of the hot coffee? So when they started this model or whatever, when they started recording the temperature, so that means basically what's the temperature when our time is zero, right? So we let t be zero, right? So then if we have e to the power of zero, that's going to be one. So then in this example, 1 times 51 is just going to be 51. So that's going to be 34 plus 51, 80. That should be 85 degrees Celsius, right? So let me see. I'm going to hit continue. And again, with this viewing example, it gives an explanation as to each part, right? So again, we just want the temperature at the start, so we let T be zero. And if I keep going, I think we said what, 80? We said 85, and you see it there, right, for that part. Okay. So therefore, the original temperature of the coffee was 85 degrees Celsius. Part B says, what is the coffee's temperature after 25 minutes? So then for part B, we just want the temperature after 25 minutes. So we just plug in 25 for lowercase t. And you can do that in your calculator. I was tempted to pull up my calculator and do it, but all we're doing is plugging in 25 for lowercase t, into this function. I'll do a quick showcase. Let me see. Calculator. It's here. I just got to do a little bit of back and forth. Oh, and I got to load this. Oof. I don't know. Let me see. Should be here. Oh, man. Where else? It should have been here. This one. That's not right. That's blank. I don't think it's there either. This might be it. Okay. All right. Let me reload and refresh. Get it to work. So now I got to do a little bit of back and forth because I'm not remembering that function. 34 plus 51 e to the power. Let's see. So I'm going to go to my y equals 34 plus 51 times e to the power negative 0.034034 t negative 0.034 t, or in this case it's x, right? And then for that part, okay, I think we're okay. They wanted, I think it said after 25 minutes. Okay. So you saw where we just typed the function in our y equals, and basically we just want to evaluate that function when, when t is 25 minutes. So on the right hand side of the calculator is a button that says clear. Left of that is a button that says VARS. I'm going to click on that, short for variables. I'm going to go to the right for y variables, number 1 for function. And basically what I'm doing is calling on the function I just typed in, and I want to evaluate this function when x is 25. Okay. So so after 25 minutes, the temperature should be 55.8 degrees Celsius. I'm going to hit continue. 55.8, right? Use a calculator. Okay, that was part B. C says, when will the coffee's temperature be 45 degrees Celsius? So now they're giving us a temperature and they want us to solve for the time, right? So they're giving us the temperature and they're asking us to solve for the time, right? So then we say that 34 plus 51e to that power equals whatever the temperature was they gave us. Equals 45, right? So we basically set this function equal to 45 and solve. Okay. If we set it equal to 45, subtract 34 on both sides, what is that? 11? 11 divided by 51. So it's going to be the natural log. We take the natural log on both sides. So again, all we're doing is letting the y side equal, I think it was 45, and then solving, all right? So I really wanted this to just be kind of like an overview. I wasn't really trying to go into details. So I'm just going to piggyback off of the this example. Okay, but we set the function equal to 45 and we solve. And so with the view and example, it kind of explains it. It's just using the model that was given, right? So then subtract the 34, divide by 51, and then we take the natural log and divide by that negative, and then that'll give us the t. Right? So you can see it here. Subtract the 34, we got the 11, divide by 51. Next, we're going to take the natural log on both sides. Right? And then divide by, because the natural log and e are going to cancel. Then we're going to divide by that negative 0.034. So whatever that number is divided by negative 0.034, then we use a calculator, we get this result. Okay, so then it's going to be 45 degrees Celsius, 45.1 minutes after being placed on the counter. And then part D says, take the limit as t goes to infinity of the function. So if we let lowercase t go to infinity, we say like as the time runs on forever. Now notice in this model, oh no, cancel. Oh no, I lost it. Where'd it go? I guess it tried to refresh. All right, so I think I'm gonna have to just refresh it. Let me see. I'm gonna click on view an example, and I think it'll pull it back up. Yeah. I'm just getting back to where we left off. Is this the same one? Okay, I think we did C, yeah. So then for D was asking, all right. Okay, here it is. So find the limit as t runs to infinity, as lowercase t runs to infinity. So if we let it cool indefinitely, what happens to our function, right? So, and I guess it's going to be the room temperature. That's going to basically be giving us the room temperature. So then here, notice that the exponential is raised to a negative power, right? So a negative exponent means it's really a fraction. So that's really 1 over e to that power, right? So there's really 51 over e to that power. So then if we write that as 51 divided by e to the power of that 0.034 times t, if we let t go to infinity, then essentially we're going to be having 51 divided by e to the power of infinity, right? Because it's going to become a really large number. E to the power of infinity is essentially infinity. So we have 51 over infinity. So we have a fixed number over a denominator that's getting bigger and bigger and bigger, right? So as that denominator gets bigger and bigger and bigger, that whole term goes to zero. So all of that 51 e to the negative, all of that tends to zero as the denominator is bigger and bigger and bigger. So then the only thing that's left is the 34. So as lowercase t runs to infinity, then, so basically if we left the coffee sitting on the counter and, just let it become room temperature, the room temperature looks like it's going to be 34 degrees Celsius. Okay. And then, we have an explanation of that here. Let me see. All right. And so this is the viewing example. You have access to this as well. So then, let's see. I guess I need to zoom out some. Let me continue. I know it's a little cut off on the right there. Again, e to the negative t, as t goes to infinity, that term goes to zero. And the limit of 34 is 34. It's a little bit cut off. You can kind of see it over here. I'm just going to kind of keep working here. Long story short, the room temperature is 34 degrees for this example. So T of T is the temperature of the coffee. T minutes have to be placed on the counter. Therefore, 34 is the temperature in degrees Celsius toward which the coffee temperature decreases over time. The coffee will not fall below this temperature. Okay, well, that's essentially the room temperature, right? So, or whatever, yeah, it's the room temperature. But, so as we let T go to infinity, as we just let it sit on the counter, it eventually goes to this temperature, okay? So, this example was mostly, I just want to kind of do a quick recap. I wish I could just see the questions. Original temperature, we let lowercase t be 0, right? And you can use your calculator for that one. If you put the t of t into the, y equals part, like y of x or f of x part, you can let lowercase t be 0 and you get your result. For B, after 25 minutes, so let lowercase t be 25, so that's evaluating the function, just plugging in for B. For C, when will the coffee's temperature be? 45 degrees Celsius. So we're setting y equal to 45 and then solving. So once you set it equal to 45, a lot of it's algebra until you get to even that's still algebra. That's the college algebra too, right? So we set y equal to 45 and solve for C. It's like college algebra too at that part. And then for D, we're taking a limit as lowercase t runs to infinity. And so the main thing is, again, with that one, we have that e to a negative power, right? So that's really 51 over e to that power. So if we let that power run to infinity, we're going to essentially have e to the power of infinity, which becomes 51 over infinity. So as that denominator gets bigger and bigger and bigger and bigger and bigger, that term goes to 0. It gets closer and closer and closer to 0, right? So then we just have 34 plus 0, which is just 34, okay? All right, so again, I wasn't really trying to work this one out. I just wanted to kind of like do an overview, right? I just wanted to kind of like introduce it and just kind of walk you through it a little bit. Hopefully that helps. If I need to write it out, just let me know. I can like go back and make another video and, kind of work out those details, but hopefully that kind of made sense, okay? And so, cancel. With that, we're going to go ahead and end the session here. And from one beautiful mind to another, have a great day. Take care. Peace.